Hey everybody, it's Dr. J, and today we're talking about valence bond theory. Let's talk chemistry. So the very first thing you're going to do is draw your Lewis-Structure. You got to know how to draw your Lewis-Structure for these, right? Once you have your Lewis-Structure, then you're going to determine the arrangement of your electron pairs based on the VSPER model. So you see, right, you got to use what you learned before in order to even do this. All right, so you got to do Lewis and VSPER. So once you have that in place, then you will select your hybridization scheme that matches your electron group geometry. So basically, you had to know your VSPER model in order to even do 3. Then you can sketch out your atomic and hybrid orbitals based on the information you have, showing the overlap of them, and then you can label the bonds sigma and pi. So essentially, right, we got this over here, right? Linear is going to be SP, trigonal planar is going to be SP2, tetrahedral is SP3, trigonal bipyramidal is SP3D, or if it's D, SP3, it's the same deal. And octahedral is D2, SP3, or SP3, D2. Okay. So this is a good chart to take a picture of, screenshot, as well as the steps over here. But everybody, this is how you're going to determine your hybridization and your bonding schemes using valence bond theory. So let's do an example, right? Determine the hybridization and the bonding schemes. Acetaldehyde. So the first thing we want to do, let's draw the Lewis-Structure. Bam. This is a Lewis-Structure here. We got our 3 hydrogens bonded to this carbon, and then our double bond to the oxygen here with the hydrogen in there. Okay, from there, we then need to determine, right, the geometries using VSEPR theory. So if I look at my left carbon, in this case, we're going to have 2 central carbons here. So my left carbon has 4 electron groups. How does it have 4 electron groups? 1, 2, 3, 4. So you have 4 electron groups. You're going to have a tetrahedral for the geometry. My right carbon has 1, 2, 3. So since it has 3 arms, right, electron groups, it's going to be trigonal planar. Now that we know the geometries, what can we do? Well, we could just match them with a hybridization. So you remember 4 is just SP3. See, look at this, y'all. It's literally telling you, right? 1, 2, 3, 4. 1, 2, 3, 4 tetrahedral. The right was trigonal planar, right? So that's going to be 1, 2, 3. Well, that's going to be SP2. 1, 2, 3. Okay, so it's literally like telling you in this case. So once you know that, then you can just draw it out. So in this case, right, our carbon, we determined it's going to be sp3. If you remember, this is a sp3 hybridization orbitals here. So once again, that's just 4, right? And then it's going to be bound to each hydrogen, which is the s orbital. And once again, all these are going to be sigma bond between these two, right? Overlapping your orbitals. And then we have our bond between our 2 carbons. So everybody, Lewis-Structure is kind of telling you how to draw this thing out. I'm going to have a sigma bond, right? Because we understand that a single bond is a sigma bond. So expect to see a sigma bond, as well as these were all single. So expect to see sigma bonds here. Now, once we get over here, it gets a little bit different, right? So now our carbon, which in this case, we said that this carbon was what? sp2. So sp2, we're going to see 1, 2, 3 for our sp2s. And then notice we got a bond to our carbon and oxygen. So carbon and oxygen, since it's a double bond, I'm going to see a sigma bond and 1 pi bond. So how are we going to do that? Well, I'm going to draw a sigma bond between my carbon and oxygen here. And then this is going to show my, what is this? Pi bond, right? So this is my pi bond between my carbon and oxygen, sigma bond between my carbon and oxygen here. Once again, the unhybridized p orbitals are doing that there. And then lastly, of course, we got our sigma bond with our other hydrogen over here. But everybody, this is essentially how you're going to be doing this valence bond theory, right? You're going to draw your Lewis-Structure, determine the geometry based on VSEPR. Then you're going to match your VSEPR to your hybridizations. And then from there, you could just draw it out. Which, in theory, you could just look at your Lewis-Structure and draw these out. Okay? Because if you go back and think about that hint there, single bonds are sigma. Double bonds are going to have a sigma and a pi bond. Triple bonds are going to have a sigma bond and 2 pi bonds.